Hello, students. Today we will be talking about some sample of exam questions and then trying to advise you on how to go about answering them in case you see them in your exam questions. Actually, these exam questions are samples of past exam questions, so pay attention to them. So let's start. So let's have a brief explanation of how the questions will look like and the ones we're going to discuss today. So the title now is Exam Questions on Design Principles. So as you know, design principles are taught in week 3. So we've done some few exercises in week 3, but in week 4 we will go through some questions that you will encounter in your question 3. So question 3 actually usually consists of questions from design principles and design patterns. So the exam will be about design principles and design patterns in question 3. So design patterns will be covered actually this week. So design principle has been covered week 3. So and the design patterns are ways of structuring code that help meet the general idea of design principles. Is the application of the design principles actually. So in this receipt questions or other questions that you might have seen in 2018, 2019, the question 3 will ask you to write some short codes to deal with programming requirements and give an example of how your code works and why it meets a particular design principle. And the best way to learn how to answer such questions is to actually practice by writing the code yourself and compiling and running them and debugging them and seeing the errors and seeing the outputs yourselves. So you have been given some coding exercises that you can download and run them on KM Plus. So part of the question 3 in year 2018 and 19 exam asks you to write a general explanation of some of the topics covered on design principles and design patterns. So you will actually need to write an explanation in English to answer these questions. So if you want to include some example codes, you're welcome to do that, which is good. But you must state in English how that code works in general principle. So in exams in previous years, so question 3 was mostly asked around written explanations, but in 2018-19 there will be questions part which you are expected to write some actual code. The slides here is based on written answer questions in question 3, so from previous years exams. So learning to answer a written exam questions, so you will need to write an explanation that shows you have a good understanding of what the question is asking you, and then you explain it. So before taking the exam, read the notes carefully and make sure you properly understand them very well. So an important aspect of getting a good understanding is to do some further reading on the same topic you've been recommended. So some textbooks that you can go through or websites. The best advice is to not try to take shortcut by attempting to memorize what is written in the notes. So it's better to understand it so that you can put it in your own words. So, and to be able to do that, you need to practice writing the programming and running them, and then you can actually understand them. So also, students will need to write an explanation that shows they have a good understanding of it, of the question that is asked. So your answer can contain just simple and straightforward explanation of what the question asks. So you can use some general idea with examples. Code, it could be code or whatever. So, and you can also mention other relevant aspects that link to what you are asked to write about. However, you will not get any marks for writing something that is not true. So you just take note of that. If you write something that is incorrect, it will just show that you don't even understand the principle that is being asked. So let's look at example questions. So the example questions in this part of question 3 given below are all written in a way that just gives general explanations in English without illustration, with specific examples. So the example answers give relevant aspects that can be mentioned in order to get more marks. Although these answers have been written in a very thorough way with enough aspects to get full marks, it is possible there are other aspects that could be mentioned that may fetch you marks too. It doesn't mean that you must follow exactly what is in the note. You just use your what you understand and then describe it. So, and if you want to answer instead of giving some coding example, that would be fine too. If you give it an example or explain it that you understand it with some diagrams, classes, or whatever, that would be great too. So let's start with questions that deal with design principles that are based on reuse of code. So what is reuse? So it means that you've written your code in a way that you can reuse it in another part of the program. For example, if you have a code about the banking system, so then we have account. So on the bank account, you will have different types of account. So if you have savings account, if you have current account, and you need to use it, so you will have a general account which will have basic components like withdraw, deposit, which all of them may have it. So they will be in the bank account class, and then other accounts can just use it and just inherit it and reuse it. Instead of having withdraw and deposit in all the different types of accounts, you just have it in one place and just reuse it. So let's see some question. Instead of writing new code for a module to provide some required service, we may make use of existing code. Explain in more detail what this statement means and why it is important. Explain how features of Object-oriented programming in Java assists in the reuse of existing code for providing new services. So let's see how we will answer this question. Now you can say, of course, it's common sense that making use of existing code saves on programmers' time, because you don't need to record it or do it, you just reuse it. So it saves your time. That's one thing you will say in the question that explain in more detail what this statement means and why it is important. So you can. So it also means that the code used will already be well developed and tested for error. So it means you have debugged it, you have run it, you have tested it on many occasions. So you don't need to, you know that it will work because you've used it before. Another thing is that the code may be well understood, okay, by its standard, making the code that use it easier to understand. So, for example, use of standard Java collections framework classes. I hope you remember collections. So they are like things like arrays, things like tables, things like maps. So these are collections. Overall size of the code you write is smaller due to lack of repetition. So what we mean by this is that it means you are not copying and pasting. You are just calling the class or just calling the methods of the class. You are not repeating it. So it will be small. So note, making use of existing code means calling existing code, not cut and paste and then copying it. So if the code needs to be modified, reuse means all places where it is used in shared way benefits of the what? Of the that's the benefits of the modification. So if code was just copied and amended, then any modification would involve finding all places it was copied to and then making the correction. This is very difficult, and modifying each of them you may make mistake. So it is better to just call it, and you can introduce even errors when you are modifying them. So the object-oriented principles of programs consisting of class that define general behavior of object as a template or recipe itself encourages reuse. That is, you put a class that another class will extend it, which means there's a super class which has general methods or functionalities. I have given example of bank account and say savings account, junior account, current account. So you can have things that are in bank account and other accounts can just take it and reuse it. So you don't need to rewrite them again. So this is right. Or you can put methods in what? In an interface, and you implement the interface. So you can just reuse them. So inheritance, of course, is what we're just talking about. It gives the inheritance gives additional capacity for reuse. So a common code will occur in one superclass and is then used or reused in classes which inherit it. So you just reuse whatever it is and add the little that you need to add. So the dynamic binding principle means code may be written with superclass types as its parameter, and the same code then used with those parameters set to a variety of subclasses. So Java's interface type mechanism enable a type to be defined in terms of a set of methods and generalized code to be written, which will work for object of any class. And what we're saying is that you can make it, you can create interfaces with with methods, and then you implement that interface using a class, and you inherit those methods, and you implement them the way you want them. So you have generalized the code, which can be used in a variety of places and may use the principle of parameterization. So, meaning as aspect of the code is given by a parameter of an interface type, whose value can be varied and provided in different behaviors. Because you can remember, in interface you don't implement it. There are no implementations. It's just the template of the method. So you can implement them in a different way. So Java also has the concept of generic typing, meaning generalized code can be written for reuse. So instead of a particular type of objects, this is usually called generic and collections that you were taught in your Java programming class in year 2. So let's look at that. We've seen questions on reuse, which is basically on inheritance actually. So some other question will look at overriding the equals sign. So we'll see overriding. Please, we have overriding, we have overloading. So let's not confuse these two things. So overriding, we will see what it is. So the question is like this. Explain what is meant by overriding equals when specifying and implementing a Java class. Explain why deciding whether and how to do this is an important decision, and the general contract that needs to be kept to when doing so. So before we even go to answer this, so to override means you must have inherited a method, and what you are doing is that you are trying to what? To write those methods in another way, but maintaining the signature. And by signature, I mean its type, that is access type, that is it public, is it private, is it whatever, and its return type, is it integer, is it void, is it float, or it is boolean, whatever it is. So you maintain it, and of course the name of the method will be the same. So every class in Java is a subclass of the class called object, as we know. So the superclass is object in Java. So it means by default all classes extends object. So there are already subclasses actually. That is because class which is not declared as extends another class implicitly extends object, as followed the chain of extends from any class object that leads to the class object. So the class object contains several methods. So these methods can be called an object of any class. One of these methods is equals. So equals, every object or every class already inherits the equals method. So you can just use it. You can just override it. Implicitly, you have what? Inherited it from the object class. So as object is a class, so there is code for these methods, of course, because in the difference between methods in an interface and methods in a class is that methods in a class, they have some implementation But methods in interface, they do not have any code of their own. They're just, in fact, templates, recipes. So it means that equals already have its implementation. So if you override it and leave it the way it is, it will return its default value. But if you don't want it to return its default value, then you have to put some extra code. That is what we call overriding. So, but it is possible to override that code, which is the equals, by providing method with the same signature in a class. I have explained what a signature is. That is, it will have the same access type, public, it will have, or public, or whatever it is, void, and it will have the same return type, or object type, and the same name type, which is equals. The dynamic binding principle means that when a method is called to an object, the code in that object actual class or its closest superclass, which contains code for that method, is used to execute the method call. So the idea of the method equals is that if you have an object, say object 1 dot equals object 2, as you can see here, as you can see here, it returns a boolean indicating whether object 1 and object 2 refer to the same objects, which are considered equal with the dynamic binding principle, meaning this is decided by what? By object 1. So the default behavior of equals inherited from object is that a call of, say, object 1 dot equals object 2 returns true if and only if object 1 and object 2 are aliases, meaning they refer to the same object. In week 3, we've taught aliases. So you know what aliases is. Means if we say object 1 equal to object 2, they have referred to each other. So they will be referring to the same object or reference point in the memory, in the address. We may decide it should return true if they refer to different objects whose content is otherwise identical, and so write overriding code which provide that. So you can decide that you want return true if they refer to different objects. It's your decision. So you can just put some if conditions in your own code. That is, now you are overriding the default. Then it will return whatever you want it to return. This is an important decision because much code, including Java's collection framework, makes use of the method equals with dynamic binding, meaning when it does so, it uses an overriding code provided in class. By dynamic binding, we mean when it is run, not during compile time. You know, you can compile a code and it can say no error. However, when it comes to run, it may give an error. And I can give you an example. For example, you can compile a code with an array that has maximum value of 100. It will, by compilation, if it's okay, it will say no error. But when you come to run it and you give it more than 100 values in that array, you say give it 150, it will have error. It will say the array is not is not up to 150. You have declared maximum of 100. So it will say if you have a loop of 100, except if you declare it's an array list, then it can expand automatically. But if you use just array, you can have, but the compilation will give you that error. There's no error. However, when you come to run it, that is what we mean by dynamic binding. When the real value, the real equal, the real code, the real object is non-called, it may give you error. Care must be taken to ensure that when equals is overriding, it still performs in a way compatible with expectation of an equality relationship, the general contract for equals, which means they are aliases. That is by default, but you can change that like I explained. The required property of symmetry means object 1 dot equals object 2 should give the same as if you put object 2 first dot equals object 1, because they are aliases. They refer to the same object. They refer to the same value in the address. So it will be true. And the same thing, the property of transitivity, okay? Transitivity means if object 1 dot equals object 2 is true and object 2 dot equals object 3 is true, then transitively it also means that object 1 dot equals object 3. It should be the same. So transitive transformation will also hold. So we have seen how to override equals, which we know it is a method in object and all classes inherit it. Now let's look at a question on inheritance and the least-scope substitution principle. So this is a question on that aspect. Another issue in Java and similar programming language is to do with variable referring to object, is that a variable has a declared type, but it can be said to refer to an object whose actual type is a subtype of that declared type. Explain the advantages which this gives, but also the problem which led to the least-scope substitution principle being declared as an important guideline for good practices. So before we answer this question, let's look at what is actual type and subtype. So the actual type is the type that the class creates, the object from the class, but the subtype is the one that you get it from the from its from what you inherit from the superclass. So can you substitute the one you inherit with the actual type or the class? So we will look at that. That is what will take us to least-scope substitution principle. This issue comes from the idea of inheritance, which enables us to write classes which are declared as variants of other classes, that is subclasses. So other classes, the subclasses, so they are you can inherit a class and are expressed only in terms of how they differ from the class they are derived from, that is the superclass. So you can have many classes that inherit from superclasses. So all of them will have like they are children of that superclass. So they are variants of the superclass. So in what way do they differ from the superclass? The difference may be additional methods that each of these subclasses that have inherited from superclass, they will have everything that the superclass have, but each of them can implement its own different types of specific class, and that's where we talk about generalization and specialization. So methods to those of the superclass, but it can also be different code for an existing method in the superclass overriding. So in as much as the subclasses can be different, they can add their own new methods, they can also be different by overriding the methods they inherited from the superclass and doing it differently. This has the advantage of reducing duplication of code, of course, because you are just calling them from the superclass. You are not copying and pasting. It's the same code that you are just calling to reuse, and different classes that inherit from the superclass can just call them. Is one code that is being called by different and inherited by different classes. So it reduces duplication of code, keeping code which performs common operations in the superclass and not repeating it in the subclasses. The actual type of an object is the class of its constructor. So the class of the constructor of that class is the actual type, but a variable that you declare of the superclass which you inherit type can be said to refer to an object whose actual type is what? Is the subclass of that type. Because you are what? You inherited it. This gives another way of avoiding duplication of code, as method whose parameters are declared of a superclass type may be used with those parameters set to refer to objects whose actual type is a what? Is a subclass of that type. So you can use a parameter because if you inherit a superclass, it means that superclass can use the subclass as part of its parameter. So it stops duplication. So this gives us generalized code which can be reused instead of having to write new codes to handle objects of the subclass types. You just reuse them. The generalized code will be for operations that only require the methods of the superclass. If you just require just the method of the superclass, but those methods could be overridden in the actual class, that is the subclass of its argument. The code of that is used to execute them in the overriding code in the subclass, just as we said. This is known as dynamic binding. I have just explained dynamic binding in the previous slides, that it is during runtime, as the decision on which code to use has to be made at runtime rather than when you are compiling it. It is when it will know which of the method it is going to use. It will see that, oh, it's been overridden, so it's not going to return exactly the way it was written in the superclass, but the subclass has made some few changes to it. So you are overriding it. So it's just few addition. So you are not, you have inherited, but you have modified a little bit. So you save your time. However, to override a method in terms of code that will compile, all that is needed is to give a new method with the same signature as the overriding method. I have explained what signatures are. So it will have the same, if it's Boolean, like in equals, it will return a Boolean type. And it will have the same name as equals. You will not change the name. But you may change what equals means. In the default, equals means they refer to the same object in the memory, but you can say equals mean they refer to different as you wish by overriding. All that is needed is to give a new method with the same signature as the overriding method, and you know what signature is now. The least scope substitution principle states that overriding should be done only with methods whose operations are compatible with the specification of the methods being overridden. So the least scope substitution principle says that the overriding should be done only with methods whose operations are compatible with the specification of the methods being overridden. So they should be compatible with it. That is, they have the same signature and all those things, and it shouldn't differ too much. This is so that any reasoning in the design and implementation of generalized code will still apply when that code is used with arguments of a subclass. If the LSP, that is least scope substitution principle, were not observed, and it was not known or planned that when code was running, its arguments referred to objects of a subclass, the code could perform in an unanticipated, even dangerous or insecure way, because you have changed the way it is. Question on aliasing. We have talked about aliasing a little bit. In week 3, we will talk about it in terms of design principles, design patterns. So this is one question on that, on aliasing. Explain what is meant by aliasing in Java programming and why care needs to be taken over the possibility of aliasing occurring. Explain how aliasing can lead to the problem of exposing the representation and why exposing the representation could have serious consequences. So let's say in Java, variables of an object type refer to objects. So remember, this is a question and this is how we are saying you should answer it. So you should explain it this way. So you should explain how it works in Java because we taught you in Java. That is the object-oriented language we taught you. So you say in Java, variables of object type refer to objects. That means they store the address in memory of the data of object rather than the actual data itself. So as a consequence, if one variable is assigned the value of another, it results in the two variables referring to the same object. That is what aliasing means. If you can say object 1 is equal to object 2, they will refer to the same object in the what? In the memory. And if they have the same value, they will have the same value. That's what it means. If two variables are aliased, it means if there is a change of the state of the object referred to, that is the state, that is the value, it could be the value. So if that object was holding, say, 3, and another object was changed to it, if the two of them are what? Are aliases, they will all have the value or the state 3. So object referred to by a method call on one of the variables, the object referred to by the other variable will also be changed as they are the same objects because they are, that's how Java treats it. If you were not aware that one variable is aliased by another, that is, they are referring to the same with another in the object in the memory, it could lead to what would be a hard to understand bug, as an object will seem to change for no reason when it was referred to in the code. So be careful when you use aliasing. So exposing the representation means a situation where variable that is a field inside an object is aliased by a variable that is outside the object. So a field, it could be if you have columns and rows, so it's a value in the field that you are filling in. So if you have an if object is aliased by a variable that is outside that object, so you are exposing it because it's outside it. This could occur, and by outside means it wasn't defined within it. That is, it was, to make it within, you make them variables as private or whatever. But supposing there's a private outside completely of the specification and you alias these two, then it is exposing it outside, where somebody can what? Manipulate and make changes without it. So it is better to make them private in one class. This could occur if a direct reference to another object is passed in through a constructor or a method call and a field variable is set to it. Or if the value of a field variable of an object type is passed as the return value, that is, it will become a return type of a method call made on the what? On the object. So you remember a method can have a return object type. So an important principle of object-oriented programming is that the internal state of an object should be changed only by the code in its own class. And how will you ensure that? You make them private to that class. If the representation is exposed, making it maybe, let's say, public to outside world, the state could be changed by other code referring to an internal object that is part of the state through the aliases. If you make them, for example, public, this would make it much harder to be certain that the code is working correctly and give incorrect behavior if it was not realized this was happening. It could also lead to the danger of breaches of security, as it may result in other code gaining access to it because you have made it publicly accessible to them. That is not meant to be directly available. And that is it for these lectures, and I hope you enjoy it. Thank you very much.